Modern industrial production relies on advanced smart machinery, integrating automation, precision, and efficiency to enhance productivity and product quality. The fastest method of tube cutting combines precision positioning with minimal handling. The procedure begins by setting the saw at a 90-degree square position, with the tube positioned exactly 12 millimeters past the blade. The first operation is a 32 degrees cut. After this, the tube is flipped 180 degrees to prepare for the second cut. The second 32 degrees cut is then performed, creating a highly accurate and clean result. A useful tip for maintaining perfect alignment between the two cuts is to use a backstop on the tube fixed at 12 millimeters past the blade. This ensures both cuts are symmetrical once the tube is rotated. The method not only reduces cutting time but also minimizes rework. For joining the cut sections, MIG welding is applied, offering high efficiency, strong welds, and smooth finishes suitable for industrial applications. The Gewinderollin M38 is a high-precision thread rolling tool designed for producing strong and accurate threads with excellent surface quality. Built with robust materials, it ensures durability, stability, and consistent performance even under demanding conditions. The M38 enables efficient, chip-free thread forming, improving productivity while reducing material waste. Its advanced design makes it suitable for a wide range of industrial applications, delivering reliable results in both small batch and mass production. OmniTrack ball transfer units offer a premium solution for smooth and efficient material handling. With over 700 different ball units available, many held in stock, customers benefit from economical and expedient dispatch. Each unit is carefully hand-assembled and undergoes 100% inspection to ensure the highest quality standards. Alternative materials and sizes are also available to suit diverse applications. Rigorously tested, OmniTrack products guarantee industry-leading performance, making them a trusted choice across multiple industries worldwide. Mechanical testing of reinforcement bars is essential to ensure strength, ductility, and performance in concrete structures. One of the most common tests is the bend test, carried out in accordance with IS 1786. In this process, a sample of TMT rebar is bent around a mandrel until a 180 degrees angle is achieved. This test checks the bendability of steel, since reinforcing bars, due to their high strength and surface ribs, may fracture if the bend radius is too tight. JSW Neosteel TMT bars demonstrate excellent bend performance compared to competitor bars. The rebend test evaluates the effect of strain aging on steel. First, the sample is bent at 135 degrees around a suitable mandrel. It is then aged in boiling water at 100 degrees Celsius for 30 minutes and allowed to cool normally. After cooling, the bar is rebent to an angle of 157.5 degrees. This procedure simulates service conditions, ensuring that the steel maintains toughness and resists embrittlement. Uniform loading and correct mandrel diameter, as specified in IS 1786, are crucial for reliable results. The permalateral system is a trenchless rehabilitation method that restores deteriorated lateral pipelines without the need for excavation. Instead of digging and replacing old pipes, this method inserts a resin-saturated liner into the existing pipeline, inverts it with air pressure, and cures it to create a seamless pipe within a pipe.
The other guy to the left, he is pouring the A side resin. It's a 2-to-1 ratio. This being a short 10-foot shot, I believe it was 6 pounds of A, 3 pounds of the B.
To begin with, the first step involves the preparation of the resin. At this stage, Doug, one of the operators, pre-mixes the B-side resin, which contains the catalyst and the hardener. Since the catalyst is lighter than the hardener, it naturally floats toward the top if left unblended. Therefore, a thorough premix is necessary to achieve consistency. At the same time, Cole, working on the opposite side, measures the A-side resin. The two parts are later combined at a strict 2-to-1 ratio. In this particular short 10-foot installation, the mixture requires 6 pounds of A-side resin and 3 pounds of B-side resin, making a total of 9 pounds. Because the demonstration takes place in Florida, where the ambient temperature is about 85 degrees Fahrenheit, the crew uses a hot weather epoxy blend. This ensures proper curing even under warm conditions. Importantly, the epoxy used is a 100% solids formulation, meaning it contains no solvents and shows zero shrinkage when cured. When the two resins are completely mixed, the liquid develops a milky consistency, which indicates that the blend is uniform and ready for use.
So all the resin is now inside the liner, a total of 9 pounds. What he's doing is calibrating his roll, his pinch roller, to evenly distribute the resin.
Once the resin is prepared, the process continues with the impregnation of the liner. At this point, the resin is poured into the felt liner, and the team ensures that the material is evenly saturated. In order to distribute the resin consistently, Doug uses a pinch roller calibration system. By adjusting the roller, he applies even pressure that pushes the resin throughout the liner while removing air pockets. Moreover, the process is supported by a vacuum system. The vacuum pulls the resin deep into the felt fibers, allowing complete saturation in a much shorter time. Consequently, with both the roller and the vacuum working together, the liner achieves full impregnation with only a single pass.
Vacuum head to the inversion head, from the inversion head. And what he's done now is he's removed the tape, which is now going to be the far end. That will be the end out towards the main. He's going to use one rubber band to give yourself back pressure when inverting the liner. And the second rubber band.
After the liner has been properly saturated, the technicians move on to the inversion setup. At this stage, the end of the liner is sealed with tape, and rubber bands are applied. The first rubber band provides back pressure, while the second secures the pull strap. This pull strap, usually blue, is later used to guide the liner into the inversion equipment. Then, the liner is placed into the inversion head, which is attached to the pipe opening. By applying compressed air, the liner is turned inside out as it advances through the pipe. As a result, the resin-coated surface of the liner comes into direct contact with the inner walls of the host pipe, ensuring a tight bond and smooth fit.
I'm just going to lubricate up the head real well. That's fine. Because all the liner has to pass through this one single point, so you make sure you get a good oil. At this point, they're attaching or just taping a guide delivery hose. This is cut specifically for 3 feet 4 inches of material. This way, that's the point.
Next, the calibration tube is introduced. This tube serves as an inflatable bladder that presses the liner firmly against the host pipe during curing. To prepare it, the crew cuts a 4-inch slit in the liner and attaches the pull strap to the calibration tube. This strap will later help remove the tube once the curing process is complete. Before inserting the tube, they lubricate it to reduce friction and facilitate smooth inversion. Subsequently, the calibration tube is wound into the inversion unit, cam-locked, and fastened securely to ensure correct alignment. By By gradually releasing the tube at approximately 8 to 10 pounds per square inch of pressure, the team achieves full expansion. Furthermore, this pressure squeezes out any groundwater infiltration that might be present in the pipe, forcing it out through cracks and joints and leaving the liner firmly in place. This outdoor
Now, once again, RJ is going to lubricate up the calibration tube to allow for easier inversion. Doug is just winding it up into the inverter. And Cole is going to cam lock the inversion head to the nozzle.
Once the calibration tube is inflated, the inversion unit is disconnected and capped. This step frees the equipment for other potential jobs while still maintaining positive pressure inside the liner. At this moment, a portable air tank is connected to ensure that the liner remains pressed against the host pipe without interruption. By keeping continuous pressure, the liner is prevented from shifting or losing contact during curing.
Cole's going to fasten just using duct tape. Fasten the liner to the front of the inversion head. That way the calibration tube has a path to follow. Doug's releasing the calibration tube at approximately 8 to 10 psi.
The curing phase itself takes approximately 3 hours at ambient temperature. During this period, the epoxy resin undergoes chemical cross-linking, transforming from a liquid mixture into a hard, structural material. Because the epoxy is a 100% solids formulation, there is no shrinkage, and the final product retains a perfect fit. Thus, once curing is completed, the liner has become a strong, seamless pipe within the existing pipe.
Now, the calibration tube is cut 2 feet longer than the liner. That way you're going to have a nice open pipe at the end. Okay, at this point, Cole is going to use the pinch clamp. This way you're keeping positive pressure on your lateral line. Because if you were to lose pressure...
Finally, after curing, the calibration tube is pulled out by means of a strap, leaving the cured liner in place. The end result is a fully rehabilitated lateral that possesses several advantages. It has structural strength equivalent to or greater than a new pipe. It also guarantees zero shrinkage, ensuring that the liner remains tight against the pipe walls. Additionally, it eliminates infiltration and exfiltration, thereby preventing groundwater from entering and sewage from escaping. Furthermore, the liner resists corrosion, root intrusion, and soil movement, which are common causes of pipeline deterioration.
Push that strap. Now Doug's going to air up, put air back on the inversion head, and Cole will release the pinch clamp.
In conclusion, the permalateral system shown in this demonstration highlights the precision and effectiveness of cured-in-place pipe technology. From the careful premixing of resins to the vacuum-assisted liner saturation, from the inversion process to the calibration and curing phases, each step is executed with accuracy to ensure long-term performance. Raytheon's state-of-the-art facility in Huntsville, Alabama, represents a major advancement in U.S. defense manufacturing. At this brand-new plant, the company assembles 2 of the nation's most advanced missile systems, the Standard Missile-3 and the Standard Missile-6. The SM-3 is a key component of ballistic missile defense, capable of intercepting threats outside the Earth's atmosphere, while the SM-6 provides unmatched versatility by engaging airborne, surface, and ballistic targets. By bringing production of these critical systems to Huntsville, Raytheon strengthens the region's reputation as a hub for aerospace and defense innovation. The facility integrates cutting-edge technology, streamlined production processes, and a highly skilled workforce to ensure reliability and performance. Ultimately, this plant plays a vital role in supporting national security, advancing missile defense capabilities, and meeting the growing needs of the U.S. and allied armed forces. Using an 80-90-watt halogen bulb as a makeshift SMD workstation is a creative and low-cost alternative to professional infrared soldering equipment. The principle relies on the intense heat and concentrated light emitted by the bulb, which can be directed onto a circuit board to loosen soldered joints. To begin, the halogen bulb is mounted securely into a gooseneck lamp. This type of lamp is chosen because it allows flexible positioning and accurate control of where the heat is applied. Once mounted, the reflector-backed spotlight bulb should be directed close to the surface of the circuit board. By carefully adjusting the angle and distance, the user can focus the heat onto the target component. After a few minutes of exposure, the solder softens under the high temperature, making it possible to remove the component. At this stage, tweezers or a desoldering tool can be used to lift the component carefully from the board without applying mechanical stress. Although this technique works, it comes with serious safety concerns. The halogen bulb produces both extremely bright light and intense heat, so protective welding goggles are essential to shield the eyes. Additionally, the work should only be carried out on a fireproof surface to avoid accidents. While effective for desoldering, this method is not recommended for professional rework, as it lacks precision and control. MTA Oddziel Elektroniki is the Polish branch of MTA, an Italian manufacturer renowned for producing high-quality electronic components for the automotive industry. With decades of expertise, MTA has established itself as a trusted supplier for leading carmakers worldwide. The company specializes in designing and manufacturing advanced electronic modules, fuse and relay boxes, and power distribution units that ensure reliability, safety, and efficiency in modern vehicles. At Oddziel Elektroniki, the focus is placed on innovation, precision, and strict quality control, guaranteeing products that meet the demanding standards of the global automotive market. By combining Italian engineering excellence with local technical capabilities, MTA delivers solutions that support both traditional and next-generation vehicles. Dedicated to continuous improvement and customer satisfaction, MTA Oddziel Elektroniki plays a key role in shaping the future of automotive electronics, providing durable, innovative, and tailor-made components for the mobility of tomorrow. The leafing process begins with each fixture receiving an undercoat of painted gold or silver, which enhances coverage and prepares the surface. Once dry, the fixture is moved to the leafing room, where the transformation takes place. Skilled artisans carefully hand-apply sheets of delicate gold or silver leaf using small tools, ensuring even coverage across every detail. This meticulous process requires several hours and often involves multiple artisans working simultaneously. Finally, the layered application creates a shimmering, authentic texture, giving each fixture a rich, luxurious finish. Uho is an innovative edible water capsule created by Skipping Rocks Lab. Made from brown algae, it is 100% biodegradable and eliminates plastic waste. The seaweed-based casing can be flavored or colored, making it enjoyable to eat or safe to discard. Already tested at athletic events, UHO promises a sustainable solution for future hydration. INA. The Sika Starbell 630 automatic beller and the Masterfit 630 IL inserter unit represent advanced solutions for the efficient production of rigid PVC pipes. Manufactured by Sika SPA in Italy, these systems are engineered to deliver high precision, flexibility, and energy efficiency in pipe socketing and accessory insertion. The Starbell 630 is a compact automatic belling machine that forms sockets on rigid PVC pipes using a thermo-regulated heating oven for uniform heating. Its mechanical mandrel system, available with optional Rebar inserts, ensures accurate shaping of sockets. By employing electric movements instead of traditional hydraulics, the system reduces energy consumption and eliminates oil-related maintenance. A user-friendly PLC interface supports quick setup, automatic diagnostics, and remote assistance, while flexible tooling allows multiple pipe diameters to be processed on the same machine. Besson. The Masterfit 630 IL inserter unit integrates seamlessly with the beller, providing inline threading and insertion of components. Capable of producing up to 1,200 sockets per hour, it guarantees dimensional accuracy, stable shapes, and excellent surface quality. Together, these units enhance productivity, precision, and reliability in PVC pipe manufacturing. The online bundling machine from Vikram Industries is a fully automated solution designed to streamline packaging operations in pipe and tube manufacturing lines. Installed directly after the cutting or finishing section, the system eliminates manual handling by automatically collecting, aligning, and bundling pipes into compact, uniform packages. The machine features precision guiding channels and synchronized rollers that ensure accurate pipe orientation during transfer. Once the required quantity is gathered, hydraulic arms and clamping devices secure the pipes tightly, forming stable bundles ready for strapping or wrapping. Moreover, the system is equipped with a programmable logic controller, PLC, that allows easy adjustment of bundle sizes according to production requirements. This ensures flexibility in handling different pipe diameters and lengths without extensive setup time. By integrating with the production line, the bundling machine significantly improves efficiency, reduces labor costs, and enhances workplace safety. Built with robust components and advanced automation, it offers reliable performance, high output capacity, and consistent packaging quality, making it an ideal choice for modern pipe manufacturing facilities. Diamonds. The homemade fan snow gun is a creative device designed to simulate natural snowfall using accessible components. This system combines water and compressed air with a high-powered fan to produce artificial snow in cold conditions. The fan generates a strong airflow that helps atomize water droplets released through nozzles. When the fine mist mixes with freezing air, the droplets crystallize and fall as snowflakes. The build is relatively simple, involving a sturdy frame, a household fan, plumbing fittings, and a compressed air source. By adjusting the water and air pressure, the user can regulate snow density and coverage. Although not as advanced as professional snowmaking machines, this homemade version effectively demonstrates the science of nucleation and freezing. It is ideal for small-scale experiments, backyard fun, or DIY enthusiasts who want to create a winter atmosphere without expensive equipment. The DEWELLI washing and stone washing machines are manufactured with state-of-the-art technology, combining technical excellence with aesthetic design. Their drive system operates through a reducer, reducing the number of belts, which lowers costs and extends service life. The machines feature both digital and electronic control panel options. A thick drum sheet ensures durability and long service life. Equipped with soft start or inverter, the engine starts smoothly, eliminating impacts and preventing free running, which prolongs belt lifespan. Additionally, tip models save time by enabling easy unloading. The cover and unloading systems, powered by air pistons, provide safe operation, reduce labor requirements, and increase overall efficiency. The creation of a solid glass mask begins with Courtney forming a clear bubble as the base. Meanwhile, Julian prepares a piece of raspberry-colored glass by heating it to the proper temperature. Once softened, the color is carefully applied to the surface of the clear bubble. To strengthen the piece and give it depth, Courtney adds an additional layer of clear glass, gradually shaping it into a glass cup. At this point, Greg joins the process by gathering a post of clear molten glass. He inserts this hot post into the colored glass cup, fusing the materials together. This technique creates a solid mass of glass in which the raspberry color appears suspended near the surface, producing a striking visual effect. With the solid form prepared, Greg moves on to sculpting the mask itself. Using traditional glass-blowing tools and a copper pipe, he carefully manipulates the molten glass. The pipe provides both support and a way to control airflow during shaping. Greg works skillfully to define the facial features, ensuring symmetry and expression while maintaining the integrity of the glass. Finally, once the mask is fully sculpted, it is detached from the pipe. To prevent cracking, it is placed into an annealing oven, where it cools slowly overnight. The Martech workshop project, the Caterpillar, is a student-designed caterpillar built by Rolf, Anders, Thomas, Lasse, and Stefan. Powered by a compact, 15-horsepower, single-cylinder, 4-stroke engine, the vehicle demonstrates hands-on skills and a spirit of collaboration. The project reflects the spirit of practical training at Martech, combining mechanical design, manufacturing, and functional testing. From concept to prototype, it demonstrates creativity, engineering competence, and the art of learning by doing. During the machining of Inconel with ceramic cutting tools, bright sparks are often generated due to the high cutting temperatures and the alloy's low thermal conductivity. As the tool engages the workpiece, extreme friction and heat cause small particles of Inconel to oxidize and burn, producing visible sparks. This phenomenon highlights both the toughness of Inconel and the cutting efficiency of ceramic tools, which can withstand higher heat than conventional carbide. The sparks are therefore a natural byproduct of the high-performance machining process. A hydraulic press line for collars and elbows is an advanced production system designed to manufacture precise fittings for HVAC, industrial piping, and rainwater management applications. This line typically integrates powerful hydraulic presses, robotic handling units, and intelligent control systems to achieve a fully automated process. The hydraulic presses apply controlled pressure to form metal into desired shapes, while industrial robots ensure efficient material transfer between stages. As a result, the system can produce a wide range of components, including elbows, collars, and other specialized fittings, with high accuracy, consistency, and productivity, meeting the demands of modern industries.